We're continuing, let me go ahead and write that. We're continuing Chapter 9, Hypothesis Testing. Remember to pause often, take notes, and complete problems on your own. In Section 9.3, we're hypothesis testing for mu, but this time we do not know sigma. So we're going to have to find something a little bit different. So the only difference between everything we did in the previous section is we're going to use a different formula for the test statistic. And that's pretty much it. And we'll have to calculate the p-value a little bit differently as well, but we're still going to be using Excel. So when we do not know sigma, we're going to be using the t-distribution. And to calculate the t-distribution, we need the degrees of freedom, and then that's pretty much it. So here's how we're going to do it. We're still going to specify the null and alternative. We're going to make sure we have the significance level. We're going to calculate the test statistic using this formula here. And then we're going to use Excel to determine the p-value. And here is what you're going to type in. Remember, the tails are determined by the alternative hypothesis. And then once you have your p-value, you can compare it to the sigma and determine whether you reject or do not reject and interpret the results. So the dean at a large university wonders if the students at her university study than the national average, ding, 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 average of 24 hours per week. So she wants to know less than, that's important too. She randomly selects 35 students, so we know N is 35, asks their average study time. She calculates a sample mean, X bar, of 16.3714, a sample standard deviation, not population, but sample, we still need it. So specify the competing hypotheses. All right, so the null and the alternative. We know we're dealing with the average, and we know we're dealing with 24. So what are they interested in? She's interested if her university students study less than the average. Well, less than does not have an equal to, so that becomes our alternative. And this is what they're interested in. The opposite of less than would be greater than or equal to. So here we go. That is that. To calculate the test statistic, so what is the degree of freedom? It's always 1 less than n. So the t-value here, we're going to use the formula, x bar, 16.3714, minus the indicated mu, divided by 7.2155 over the square root of 35. So carefully type that into your calculator, and you should get negative 6.255. So that is our test statistic here. And if we take a look, so that's our test statistic, to find the p-value. So remember that that's all the way, remember the t is approximately normal. It's all the way over here. And our claim is left less than. And if you recall from the t-distribution, the t is actually reverse. It always gives the right side. So we know because that this is left-tailed, because of that alternative hypothesis, it's going to be 1 minus. And if you don't like that, you can always just use this as a table reference. It's left-tailed, so we're going to be using this here. So we're going to go into Excel to find our p-value. Because it's left-tailed, it's the opposite for the t-distribution. T.dist 1 minus negative 6.255, and our degrees of freedom is 34. So our p-value, what does that e mean? The e means like that's how many decimals you have to move it. So it's 0.00000. So it's our p-value is approximately 0. So now we have the p-value. For D, at the 5% significance level, so our alpha is 0.05, what's the conclusion? So how does P compare to 0.05? Our P is 0. Well, that's clearly less than. If the P is low, the null must go. So we're going to reject the null. So what is the conclusion then? If we reject the null, then we're essentially supporting the claim. So we can say that there is sufficient evidence that the average study time would be less than 24 hours. And here is the work as well. All right, let's do another example. All right, research finds that today's graduate students study an average of 14 hours. Use the sample data from this file. The dean would also like to test if the mean study time of the students at her university differs from the average of 14. At the 5% significance level, what's the conclusion? Even though they don't ask for it, we always have to write the competing hypotheses. So we're talking about average, and we're talking about 14. So in this case, they want to know differ, so difference, so not equal to. This is the claim, and this is the null. So we have to use Excel because we don't really have much here. So let's go in. In this case, we can see here that there are 35 values. So we know that the n is 35, which means we know that the degrees of freedom is 34. And we need S, right, to calculate that, and we need x bar to calculate. Remember, so our t value is equal to x bar minus mu in question s over n. So we need the s and we need the x bar, and we can get that from Excel. So x bar is our average, so we'll calculate our average here. And we get our x bar is 16.37. And we get our sample standard deviation, is I lost it, sorry y'all. Our sample standard deviation, let's scroll back up, 7.22. And I'm just going to go ahead and calculate it right in here so you can see. So if I'm going to do this, it's going to be the average, and I'm going to use a parenthesis for the top, average minus the mu in question is 14, divided by the sample standard deviation, divided by the square root of n, which is 35, and I get that my t, in this case, is equal to 1.944. So we are dealing with a two-tailed test because of this not equal to. So we know that it's going to look there's 1.944 and then negative 1.944, and we know it's going to be both here. And because we have this positive t-value, the t-distribution table always gives us to the right. So it's going to be 2 times this p-value here, 2 times that. So if we type that into, and again, if you don't like that, you can just use this, two-tailed. We know that. So two-tailed, we're going to do is equal to 2 times t dot dist dot rt 1.94434. And we get a p-value of 0.06. P is equal to 0.06. Now, we're going to compare that to the significance level of 0.05. So how does 0.06 compare to 0.05? So I always start, first digit is 0, that's the same. Second digit is 6, this one's 5, this one is bigger. The p is low, the null must go. The p is high, do not reject the null. Which kind of says accept the null, which means there is insufficient evidence to support the claim that it differs. We cannot conclude that. And there you go as well. That's your textbook. And we'll do another example together. So the manager of a small convenience store does not want her customers standing in line for too long prior to a purchase. In particular, she is willing to hire an employee for another cash register if the average wait time, so we're talking about mu, is more than 5 minutes. She randomly observes the wait time, and here we go. So A, the null and alternative hypotheses. So we know we're talking about mu. And we know we're talking about 5 minutes, and more than. So more than doesn't have equality. And this is the claim, or this is when they're going to hire someone. So if it's got more than 5, they're going to hire, more than 5 minutes, they're going to hire someone. The opposite is less than or equal to. So now let's use Excel to calculate the test statistic and the p-value. So we have nothing but this raw data, but we can type all this data in. So we've got 3.5, 5.8, 7.2, 1.9, 6.8, 8.1, and 5.4. So if we want the test statistic, remember our test t, the degree of freedom, and then we've got this is our formula. So we know n, actually. There are 1, 2, 3, 4, 5, 6, 7. So we know our degrees of freedom is 6. So our test statistic, whoops, that should be a 6. All right, we need the average of these. So let's get the average. And we need the standard deviation. All right, so the test statistic is going to be equal to the average minus the mu in question divided by the sample deviation. And you know what? Oops, we're going to start over. I want parentheses. Minus 5 divided by parentheses sample standard deviation divided by the square root of, there are 7 of them. So my test statistic is 0.64. And it is a right-tailed test. So because it is a right-tailed test, we are just, that's the good news with these. We don't have to subtract anything if it's a right-tailed test. So our p-value is going to be equal to t.dist.rt 0.64, comma, degrees of freedom is 6. So our p-value is equal to 0.27. You could say 3. All right, so we calculate that. What assumption regarding the population is necessary to implement this step? So it's necessary to assume that it is normally distributed here. So decide whether the manager needs to hire another employee at alpha equals 0.10. So let's compare the p. So 0.273, how does that compare to 0.10? So first digit, it's already greater than. So we're not rejecting the null. If we do not reject the null, then we're saying it is less than 5. So if it's less than 5, they do not need to hire another employee. And that's it written out for you. And then go ahead and give these two a try. Press play when you're ready to see the solution. And that concludes 9.3.